Hello everyone, in this video we're going to talk about how we can perform some operations on functions. So there is a way to do this on the calculator, on the TI-84 Plus CE graphing calculator, and I'm going to do a video that'll actually be the next upload that I have after this video. So in this one we're going to talk about how we can do this algebraically or by hand. So it says let f and g be any two functions. A new function can be defined by performing any of the four basic operations on f and g. So these four basic operations we see in this chart here are addition, subtraction, multiplication, and division. So let's focus on addition first. We see the operation, then we see the definition. Basically we're saying, okay, f plus g of x is equal to the f of x plus the g of x. So we're adding the two functions together. So when we look at that as an example, if on all four of these examples, f of x is going to be equal to 5x and g of x is equal to x plus 2, so just a couple linear functions there. So for addition, we're going to add them. So it's just 5x plus x plus 2, and we just combine like terms to get 6x plus 2. So the resulting function from adding f and g would be 6x plus 2. Now for subtraction, we say f minus g of x is equal to the f of x minus the g of x, and we would just subtract 5x minus x minus 2, or x plus 2. So in this case, we distribute this negative, so 5x minus x would be 4x, and then we have a negative 2 at the end, so the resulting function would be 4x minus 2. For multiplication, we're going to say f times g of x is equal to the f of x times the g of x. So now we would take 5x and actually multiply it by x plus 2. And so in this case, the resulting function would be a quadratic function, 5x squared plus 10x. Now for division, we're going to do f over g, or f divided by g of x, is equal to the f of x divided by the g of x. And so in this case, we would do 5x divided by x plus 2. And so when we do these operations, we have to think about the domain a little bit. So the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. So when we're thinking about the domain of our final function, or the result of doing an operation, we need to consider the domain of the two original functions as well, and that's going to impact whatever the domain should be of our final function. Now, the one operation that we need to be careful with is division. It says the domain of the quotient does not include x values for which the g of x is equal to 0. So the reason why g of x is because we're dividing by g of x, and as we know, we can't divide by 0. So that's just one little caveat that we have to remember when talking about the domain. So we're going to look at four examples, one for each operation. So for example number 1, we have f of x is equal to 5 root x, and g of x is equal to negative 8 root x. We want to find f plus g of x. We're going to state the domain, and then we're actually going to evaluate the sum when x is 64. So we're going to add these two together. So f plus g of x, so we're going to say f plus g of x would be equal to, and we're going to add, so 5 root x plus negative 8 root x. So in this case, we're just adding like radicals, and so we could just do 5 minus 8, and this is going to give me negative 3 times the square root of x, and that would be my new function. So now let's talk about the domain. Okay, so our two original functions, f and g, were radical functions or square root functions. So if we think about that, when we look at the graph, it's going to kind of go up to the right like that, or it's only going to include non-negative real numbers. Okay, so non-negative real numbers would be our domain. Okay. Now it says evaluate the sum when x is equal to 64. So we could actually write it like this: f plus g of 64 would equal, well, we know f plus g is equal to negative 3 root x. So we could say negative 3 times the square root of 64. So negative 3 times 8, and we get negative 24. Okay, so that would be our first example on how to add two functions. All right, example number 2. f of x is equal to 2x cubed plus 4x squared minus 8x plus 4. g of x is equal to 3x cubed minus 5x squared plus 6x minus 9. We're going to find the f minus g of x, state the domain, and then evaluate when x is equal to negative 1. So we are now subtracting. So we're going to say f minus g of x is equal to, and we're just going to write these two functions, 2x cubed plus 4x squared minus 8x plus 4. Now I'm going to subtract the g of x function, 3x cubed minus 5x squared plus 6x minus 9. So now we're just back to subtracting polynomials. So let's go ahead and rewrite everything here. So 2x cubed plus 4x squared minus 8x plus 4. Now I'm going to distribute this negative. So minus 3x cubed plus 5x squared minus 6x and then plus 9. Okay? Now what I like to do is kind of underline or put some kind of similar marking under my like terms so I know what I'm combining. So that was 2x cubed and we have a minus 3x cubed, so that's going to be negative x cubed. 4x squared, 5x squared, so plus 9x squared. And then we have negative 8x and negative 6x, so minus 14x. And then we have plus 4 and plus 9, so that would be plus 13. Okay, so this is what our resulting function would be. Negative x cubed plus 9x squared minus 14x plus 13. Yeah, so talking about our domain here. Okay, so our two original functions were cubic functions. And so in this case, we're going to say essentially all real numbers as well for the domain. Okay, we're including all x values here. All right, and now we're going to evaluate when x is negative 1. So we could say f minus g of negative 1 is equal to, and we're just going to plug negative 1 in for all of the x's that we see in this expression that's in the box. So negative 1 cubed plus 9 times negative 1 squared minus 14 times negative 1 plus 13. So negative 1 cubed would be negative 1, and then make it opposite, so positive 1. Negative 1 squared would be positive 1 times 9 would be 9 plus 14 plus 13. So this is going to be 10 and this is going to be 27. So my answer would be 37 when x is negative 1. Okay. All right, there's our subtraction example. Now let's take a look at multiplication and then division to finish off. So number 3, f of x is equal to x cubed, g of x is equal to the square root of x. We want to find f times g of x. We'll state the domain once again. And then we want to evaluate when x is 4, okay? So we could say f times g of x is equal to x cubed times the square root of x. Now, for this one, I'm going to rewrite x, or the square root of x, as x to the 1/2 power. So I'm going to say this is, actually we'll do it down below, x cubed times x to the 1/2. So now what that allows me to do is use a exponent rule. Because my bases are the same, now I can add those exponents, okay? So this is going to be equal to, so we just do 3 plus 1/2, so 3.5, or we could write that as a mixed number, 7 over 2, okay? So we're actually going to leave our answer just like this, so x to the 7/2 would be our solution there. Now let's think about our domain. So we did have x cubed, which would be all real numbers, but we also had square root of x, so this is once again needs to be non-negative real numbers, because that is what the domain would be for our g of x function. Now we want to find the f times g of 4. So we're just going to plug 4 in and do 4 to the 7/2. So to me, I can rewrite this as 4 to the 1/2 raised to the 7th power, right? I'm like undoing the power product rule. So this becomes the square root of 4 to the 7th, which would be 2 to the 7th. And we would know that to be, well, 2 to the 5th is 32. 2 to the 6th would be 64, so this would be 128, okay? And that's our multiplication example. Last one, we'll look at division. So f of x equals 4x, g of x equals x to the 2/3. Find f divided by g to the x, not to the x, of x. State the domain and then evaluate when x is 27. So we're gonna write f over g of x is equal to 4x divided by x to the 2/3. Now, once again, I can use an exponent rule because this would be like 4, and then we have a division, right? X to the first, essentially, divided by x to the 2/3. So our exponent rule tells us if we're having the same base and we're dividing, we can subtract those exponents. So this would be 4x to the 1 minus 2/3. So 4x to the 1/3. So we could leave it like that, or you could write it as 4 times the cube root of x. I'm just going to leave it as 4x to the 1/3. So now let's think about the domain. Okay, so the domain, we had a linear function, so all real numbers, but then we had x to the 2/3. So if we think about x to the 2/3, that would be like the cube root of x to raised to the second power. So we can say all real numbers for this one as well. Okay, and now we're going to evaluate. So we're going to say f divided by g of 27, and we're just going to plug in 27 for x. Okay, so let me put that 1/3 on the inside of those parentheses. All right, so this would be 4, and we know this would rewrite as the cube root of 27, and the cube root of 27 is 3, so my final solution there would be 12. Okay, and that is how you can perform operations on functions.